first of all, for being here, taking this time. My name is Gus. I am currently working for Netgear, celebrating my second year anniversary today. Actually, 2 IBCs ago, I started, and I'm proud to have survived. Well, today we are going to talk about how to think your network from the protocol or from your AV over IP transport of choice, right? So has everybody ever tried anything with a protocol called Dante? Yeah, very much familiar? Anything with something in the video aspect like NDI? Yeah? So these are proprietary protocols. That's maybe something that not everybody understands, but in short, anything that is proprietary has one company supporting that. And open standards or protocols or technical recommendations are then based on the alliances that Tina was starting. I will focus on the open standards today. I think that IPMX and ST2110 are in kind of the buzz for this show particularly. So every time, and this is my agenda, but at the same time is like your checklist for your next project that you will start. I suggest you always start deciding the application or listening to your customer, but once that the use case part is sorted, you will have to choose an AV over IP protocol just to stay within a certain ecosystem, right? So if you are seeking interoperability, there are interoperability options also with the proprietary protocols. But today we're just going to focus on open standards. If your protocol requires timing, synchronization to the very detailed level, this is a must. You need to take that into consideration at the very beginning of your process. I am talking about PTP, but we're just going to talk about synchronization in terms of many interactions that must be live and instant, and you cannot face or tolerate any delay. Some other applications like a single source to single destination, maybe you don't need much of that. Then you will have to calculate your bandwidth. So bandwidth sometimes sounds like something that goes like this, as in a width. I prefer to talk in speed. So if we educate ourselves to think of how fast our lanes must be to transport everything, I think we do ourselves a better job in naming things right. So let's talk about speeds as well today. Finally, you will want to start your project today and make it survive for the next, hopefully, and I would say at least 3 years. Guys, 3 years is nothing. But in 3 years, I expect our industry and let's say the world to change a little bit. So we need to prepare for scalability, also for things that we not yet use or we are not even considering. So always start your project thinking of the day, the moment, also the bill that you will charge your customer for scaling that. Finally, techniques as in optimizing your cabling infrastructure with PoE. Everybody familiar with PoE here? Yeah? Great. And also redundancy. I want to pick your brain here. Who has ever worked in an IP media system that needed redundancy? If you want to share your experience, just pick the microphone, please, sir, if you can share. Can you share?
Oh, I mean, it's just all of them.
All of them.
Yeah. No, it's
just for the recording, please. Yeah.
Sure, no problem. So, I mean, when you're doing, high-profile events, contribution, quality video, everything has to be fully redundant. If you're not doing that, then you're just begging for trouble. I mean, there's always going to be something failing.
Definitely. I just want to comment on that because redundancy is measured in levels, right? Theoretically, there is no full redundancy. Otherwise, you will have to have 2 talents, like the cover band right there, the tribute band, 2 cameras for everything, 2 or more. So we have some strategies to improve your redundancy within the network. Finally, the topology design and optimization. So has anyone here ever seen a network topology where you literally see the switches connected to the routers, connected to the APs, and then all the physical connectivity, well, that should give us a little map, but as we know, in the IP realm, everything works in logic. So sometimes we will see something that is connected, but not necessarily everything is going from point A to point B exclusively, right? Just leveling up a little bit of our understanding for the conversation here. Well, I'm proud to be, as I said, celebrating my second anniversary in this company, which has been the one switch manufacturer that has heard the industry and has understood that you not always will have the chance to just work with one protocol. And as we said before, scalability means being ready to rock with the next improvement, with the next development that the industry might show us. So Netgear AV is currently supporting over 480 partners, which are, I think, 200 just in this show. And if you go to ISC next year, you'll probably see the other 300 there. We are, let's say, working as much as we can to simplify networking deployments for AV professionals. Basically, we want you to see our Netgear switch and just trust it. Say, okay, I know the ports that I need. They are configured the way I need. All of this configuration, we made it easy with a profile. So what we, as Netgear, call profile entails is a big list of configuration that are optimized for your Dante, for your NDI, for IPMX, for ST2110, and even hybrid networks, which is the topic for today as well. So I want to start just saying that in our case here, if you think of the average AV mindset, we want to control, we want to see the lights flashing, we want to monitor everything, we want to be in full control of our network and endpoints. So Netgear offers a software that is free for download, and you don't even need to install it anywhere. You can just walk around with it on a USB stick, stick it on a computer that is, of course, connected to the network, both wirelessly or wired, and the software will discover automatically all the Netgear switches that are in place, allowing you to have instant visibility of your topology. The software is very complete. I just want to pitch some of the trainings that we do at the Netgear Academy that is dedicated to the software, is the Netgear AV Level 2 certification, where you can have a little, like a tour on the software and on its capabilities. Once again, it's free. You can download and stick it on a USB. Hopefully we'll have some cloud implementation in the future. Well, with Engage, you will be able to visualize. I know that it's probably hard for you guys to see over there, but trust me, what I'm showing on the screen here is our topology view, where the switches are displayed, like a little thumbnail that reflects the unit, and you can see the uplinks. And by double-clicking any of these uplinks, you can see the traffic. Why does that matter? For example, please, just use the microphone, please, my friend.
How does it work? Through SNMP or HTTPS in order to discover the devices?
So we use MDNS to discover our own devices, and then with a little handshake, they start exchanging information. So SNMP is also capable. Our switches and Engage itself could serve as an agent for SNMP servers. But as a company, I would say we are acknowledging the historical contributions of SNMP, but we're certainly looking for more API-based and libraries that end users, integrators, or other manufacturers could also have in their hands. Good? Please, one more question. Microphone, please.
How do you provide network security and integrity? How do you make sure that somebody that's getting on with your software is authorized to be talking to the devices that they're connecting to, especially in the automatic realm?
Sure. Well, all of the devices that are discovered, they are discovered after you create an account with the software, so you're locked behind your password. And here on the top is very small, but the same software could be controlling several networks. Once you have visibility to the network itself, you could even go as far as putting one password and a limited set of users for each site, as we call it. Just think of a site as a as a collection of devices in a certain venue. So this is definitely protected by passwords, and if someone will simply plug in a computer in one of those ports that should be available, they will not be able to see it. I mean, they can have Engage themselves, they can have their own accounts on Engage, but if Engage under another account has already onboarded these switches, they are locked in. Okay, good. So far I have the answers, please.
Can I just quickly clarify, does that include networks that are isolated from the internet?
It is isolated from the internet.
They can be isolated from the internet, you can still do all the logons and things. It's
Absolutely. You need no internet gateway to talk in the LAN, let's just say it like this. Well, after discovering all the devices, you will start configuring. I will try to be fast in the next 20 minutes, just showing you what devices we would see mostly being recommended for IPMX and then for ST2110 at the end. Well, our, let's say, flagship and best sellers are the entry level, which are the M4250. Just take a little mental note of this 4250. The numbers will grow as the capabilities will grow, but this is the bottom level where most of the switches are 1 gig on the access ports, 10 gig, either copper or fiber on the uplinks, PoE to a certain level, because we understand also that PoE is what makes a switch mostly expensive. And on the M4250 line, you will not have redundant power supplier. So we can call it an entry-level switch. Very affordable. There are units that start from 500 euros with PoE, with all the AV profiles that I mentioned. So with a simple, let's just call it not simplistic, but simple as in humble, M4250, you can have it all. You can have your NDI, your Dante, your IPMX. You can have the so-called 1 gig world flying through these ports here with all the best of your capabilities. You can split the ports into different VLANs as one would. You can interconnect the devices and just build and keep on scaling. Engage will always recognize a new switch. If you have already some, let's say, site-wide rules and policies, the new switch that will come into that will just adhere and adopt those in terms of DHCP, VLANs, ports, etc., etc. Some of the faster, as I was saying, more bandwidth but faster devices we have will also have fiber ports that can be lagged, that can be aggregated together. And this process of lagging two switches or, please.
No, I was waving at the child.
Ah, the children. Are you learning something? Okay, good. Well, the process of grouping ports together to increase the speed is called lagging. And on our portfolio, we have very good features that automatically do this for us. This here is our, let's say, core device within the M4250. When I say core, it's not that it's my favorite, it's just that it could be placed at the core of your network, and because it has only fiber ports, it is certainly not expecting end devices, endpoints. So this one at your core, 16 times 10 gig, connected to one of the most simple ones, you are in 1, 2, 3 switches ready to have and deploy a robust, I would say, robust and solid network. Well, after you have...
When you have 16 10 gig ports, does that mean you have 320 gigabit backplane on there? Or?
Yes, sir.
Okay, so it's full line rate, no restrictions, okay.
Correct. Are you familiar with what the question was about? Non-blocking architecture? So basically what he said is if one elephant can come through each of these ports, all the elephants can coexist in the room inside. Okay. And yeah, you're fast on the math, so kudos. Well, once you have, of course, the physical part set and done, you will want to logically break that into virtual local area networks that I just have a little representation here of how that would be. In our Engage software, this refers to the profiles. Once you have many devices that are interconnected, every port that will be carrying data from multiple VLANs will be automatically configured as a trunk port. allowing multiple traffic from multiple VLANs. Okay, so I know it's a little bit hard for you to see, but just try to concentrate on this topology. We're going to be building on it. So as I said, we have our fiber port 16X. The models at this point don't matter much, but just like think of a fiber port core, very fast with 320 gigabits backbone. And then you start putting your, in this case here would be almost like an aggregation layer and some edge access layers here on the bottom. All of this can be broken into as many VLANs as you wish, and because we offer the simplified AV profiles, you could just add the protocols that you wish. Of course, each of them will be initially contained into their own VLAN, which sometimes is what you want, and you can simply accomplish that in a few clicks with our Engage software. Well, as I said, once the ports detect multiple traffic from multiple VLANs, they automatically configure themselves as trunk. Now, we're going to get to something that Netgear does very well, which is the control of something we use a lot in AV over IP, which is multicast. So primarily, initially, originally, let's say before multicast was carrying so much data as we have in AV, multicast was not that much of an issue with a few kbps. So multicast traffic should always come from the access back to the core, check the list of subscribers with the IGMP querier or boss of that whole multicasting, and then back. So this becomes a little bit problematic if you're working with video. If all the video that you want to split to multiple receivers needs to traffic all the way in the network just to know where to go, becomes a little bit complicated, and it will saturate your uplinks, will oversubscribe. The symptoms when this happens are certainly visible. You're going to lose frames, you're going to see glitches, you're going to probably see that the whole thing is not working. You're going to blame the network, but just remember, with companies that are looking for these challenges, as we have solutions that are one click away. But how the solution works is, I'm sorry for this maybe not too clear picture here, I'll try to explain it verbally. As I said, in these two switches, we can have multiple protocols, multiple VLANs. But let's say that we have a VLAN here, another VLAN here that are the same VLAN ID, and another VLAN here that all the receivers are contained into the same local switch. They are connected physically to this local switch. Our IGMP Plus would, instead of obliging all the multicast to go up to the querier and then come back, we can say, well, if all your subscribers are here, you don't need to go back to the IGMP querier. We call it a layer 2 multicast control method. Behind the scenes, what we are doing is that we're blocking all multicast on all uplinks, and we are sharing the vital information with the transmitters where they need to go, and then the switch, if there is a receiver on the other side that is subscribed to that multicast, just that flow will then be traveling across all the uplinks to the receiver. In a micro star topology like this one, it's easy to see the advantage. But as you scale, this becomes intricate. And we as AV over IP engineers, we just want to have freedom to keep on building on our networks. Without IGMP, the scenario would be a full multicast flood. Again, loss of data will be just dropped. Again, the slide is a little bit wiped out for the light here, but without IGMP Plus, all multicast, regardless of where the receiver is, must go back to the core in this sense and check with the IGMP querier what would it be doing. If you still need more bandwidth, we're still talking about the M4250 products here. If you need more bandwidth, you can group ports together, particularly on the uplinks, and allow two ports to work as a single logical link. This scenario is very common. However, if you simply do this without worrying too much, you may create a loop in your system. So particularly broadcast messages without lagging could come here, get here, and be looping in, again, bogging down, slowing down your network. That's why in our switches, we have a feature called auto lag that will simply understand that, particularly with broadcast messages, and will say, well, these two ports are now working as one. Let's just allow this to happen. To conclude this network, as I see we're turning back now, right? I want to showcase the M4350 line, and I'm just going to show a nicer topology here where we could have this kind of clearly visually represented. Don't need to talk much about configuration at this point. Here, one back. Well, IPMX is tailored to be very flexible. It could potentially and theoretically can work with any size, right? We can work with any quality, any uncompressed or compressed. It could be working also with higher bandwidth traffic, but let's say it's oriented to the 1 gig market. ST2110, on the other hand, is definitely not on the compressed market. It must work with uncompressed video. It must work with live, real-time interaction of multiple teams on that. So in a scenario where you would have part of your network that is IPMX and part of your network that must be ST2110, you can still use that engaged software. You can still control all of, let's say, the variables of your network from the single pane of glass, having part of your network with the simple 4250s, the other part of your network with the more advanced, therefore also a little bit more expensive, 4350. So, just in a nutshell to conclude, our recommendations would be for IPMX networks and IPMX devices in general, make sure that you first decide the timing aspects as we have discussed it earlier, if IPMX will be PTP based or not for single source, single display applications. For ST2110 devices, make sure that you configure the VLAN where all these ST2110 devices will be residing. That must then comply with the BC, boundary clock control, GMs, and all the controls that we also offer in terms of NMOS and etc. The full stack of ST2110 is supported by our M4350. Double check that all devices are correctly configured to work as you want. Finally, use the M4350 ability to handle both. Of course, like the better can handle the least required, the least picky protocol. So if you create a system where on your core you have an M4350, M4250 for the IPMX, M4350 for your hybrid networks, you will be able to just like fly on the best highways for the AV over IP. Finally, I just want to summarize that M4250 for cost-effective deployments, M4350 when you want and need the full ST2110 support, auto lag, auto trunk, IGMP plus, let's say the best features of Netgear are automatically there. You don't need to do anything. And then at the end, just make sure that you perform the firmware updates as we get along. Hopefully you found a little bit